Hey guys, welcome back in. Mr. Marone here. So we are in our final video for topic 2. We are on lesson 2 for day 2, and we're going to be talking about perpendicular lines. And we said perpendicular lines are two lines that intersect and create a right angle at their intersection point. That's what we've kind of used as our working definition of perpendicular lines. At this point now, we're going to take a look at them on the coordinate plane. So if we look at our theorem here on perpendicular lines, it says that two non-vertical lines, so it's that same comparison you guys saw last night with non-vertical and vertical. Non-vertical lines are perpendicular only if their slope multiplied together, the product of their slope is -1. So when I multiply my two slopes together, you're going to have to multiply some fractions. The slope would equal -1. That's the big key here. And then if I have a vertical and a horizontal line, like a y equals 3 and an x equals 2, those are going to be perpendicular as well. Those are the easy ones to see. It's these non-vertical ones that are much more difficult to see. With that said, let's try this. So it's the same process we had in our previous video, only now we're looking for perpendicular. So lines J and K. It appears that I've got a point for J at, looks like 3, -1. And I have another point at 1, 2. So the slope of that one, -1 minus 2 over 3 minus 1, is going to give me -3 over 2. If I'm now looking at K, it looks like I have a point at -3, 2, and I have another point at 4, 0, 4. So if I check my slopes there, I'm going to do 2 minus 4 over -3 minus 0. And that's going to give me -2 over -3, or 2/3. Now, if I multiply -3 halves times 2/3, -3 over 2 times 2 over 3. If you need a reminder, you multiply the tops and multiply the bottoms and then simplify. So I've got -3 times 2, which is -6, and I've got 2 times 3, which is 6, and that simplifies to -1. Since their slopes, the product of their slopes is -1, these are perpendicular. So we can say that line J is perpendicular to line K. We use the upside down T because we're lazy mathematicians. Go ahead and try examples 4 and 5 here. You're looking for lines H and L and lines M and K. Alright, welcome back in. So as you can see in example 4, I ended up with slopes of 2 over -3 and 5 halves, and when we multiply them together, that is not equal to -1. And then if I look at my example 5, I got slopes of -4 over 1 and -2 over -3. When we multiply those, we get 8 over -3, which is not equal to -1. So now we get to the final piece of this, which is taking a point and a slope, like that point-slope form in our review video, and creating parallel and perpendicular lines to a given line. So we've got two examples here. First thing they want us to do is they gave us an equation, and they want us to create an equation of a line through this point P that's parallel to the given line. So if we think about it, parallel means same slope. So the first thing I need to do is pull the slope out of the equation that they gave me. So in this case, my slope is 1/2, and then they gave us the point P, which is equal to 4, 1 as its coordinates. At this point, we just use point-slope form, which is y minus y1 equals the slope times the quantity x minus x1. And this is x1, y1, and I have my slope. All I have to do is plug in. So I've got y minus y1, y minus 1, equals my slope of 1/2 times the quantity x minus x1, which was 4. At this point, you can leave it like that, or you can write it into slope-intercept form. Be careful to read the directions on what they're asking. If we put this into slope-intercept form, I would have y minus 1 equals 1/2 x minus 2. I'm going to multiply this 1/2 to both, and then I'm going to add 1 across. So I'd have y equals 1/2 x minus 1. And that right there is going to give me the graph. If we tried this, if I went down 1 over 2, down 1 over 2, I would go through the point -1, and I would have a parallel line if I could draw straight lines, just like that. Now, for perpendicular, it's really the same process with one very minor tweak. So I'm going to have the same line, this is the same picture, we're now doing perpendicular at that point. So when we think of perpendicular, that means that the slopes product are -1. There's another way of thinking of this. There's a term called the negative reciprocal, which means that you flip the fraction and then change the sign. So what you're going to do is take the slope of 1/2 and you're going to flip the fraction so it becomes 2/1, and then you're going to make it negative. That right there is going to give you what slope would create a product of -1. 1 times -2 over 2 times 1 is going to give you a -1. So right here, that's my slope for my perpendicular line. They gave us the point of 4, 1, and we just used point slope form. So I'm going to do y minus y1, which is y minus 1, equals my slope of -2 times the quantity x minus 4. And if you wanted to get into slope-intercept form, it would be y minus 1 equals -2x plus 8, negative times negative, and then I'm going to add 1. And that's going to give me the line y equals -2x plus 9. So that's it. That's all there is for parallel and perpendicular lines in a coordinate plane. If they're parallel, they're going to have the exact same slope. If they're perpendicular, the product of their slopes is going to be -1. If you guys have any questions, feel free to bring them into class tomorrow and we can discuss them. And have a wonderful evening. Bye-bye.